Section 21, Section 4, balancing redox equations with oxidation numbers. You've already learned how to balance equations a while back, so we're good there, but sometimes we have some tricky ones, and one of the methods that we can use would be to look at oxidation numbers. I'm going to show you one that would be really easy to balance without, just so you can see the process. So if we take FeCl3 plus zinc, that's a single replacement reaction, so I know it is a redox reaction. And we will get zinc chloride and iron. So again, go through, check your oxidation numbers. This is 0, it becomes a 2 plus. This will be a -1, this will be a -1. Here iron is a +3, and here iron is 0. And so we can see the changes here. You can see that this increased by 2. Okay, so we have a loss of 2. So I'm going to write that up there, of 2 electrons. And then we have our iron here that decreased by 3. In other words, we have a gain of 3 electrons. Now with redox, they go hand in hand, and the number of electrons lost must equal the number of electrons gained. So when you take a closer look at that, in this case you look for the lowest common multiple, and that's going to be 6. So we'd have to multiply this by 3 and this by 2. So what does that mean? It means that I'm going to have to multiply my zinc by 3. And if I have 3 zincs here, I need 3 zincs here. It means I'm going to have to multiply my iron by 2. So if I multiply that iron by 2, I have to have 2 irons on this side. And then double check your chlorines. You've got 6 and 6. So again, this was an easier one, but I just wanted you to see the concept behind this. Okay, let's take a closer look at one that's a little more difficult. We'll have zinc reacts with nitric acid to produce zinc nitrate. That's a 2. Hopefully you can see that. And nitrogen dioxide and water. And again, what makes this one really difficult, you can see a split of nitrogens and a split of your oxygens. And so when you're going to balance this, we don't always know where to start. So again, go back to your oxidation numbers. This is 0, this is a 1 plus, this is a 2 minus. You're going to have to calculate what your nitrogen is. It turns out to be a +5. Here your zinc is a 2 plus, your oxygen is a -2. On this one, your nitrogen is still a +5 because it's still in a nitrate. Here it will be different. Here you've got a -2 here, so that's going to mean that this is a +4. Your water +1 for your hydrogen and -2. So when you look at what's changing, you've got your zinc changing. And so here we have a loss of 2 electrons. And then you've got this nitrogen compared to this nitrogen. And you have a gain of 1. Okay. So lowest common multiple is going to be 2. So I'm going to need to multiply this by 2, which means I need to multiply this by 2. Okay. This is just a hint. This doesn't make the whole thing balanced. But from here, it gave me a start, and now I can start looking at it more closely. So here, I have 2 nitrogens. I have 2 nitrogens here, so I have a total of 4 nitrogens on this side. So I need a total of 4 nitrogens on this side. So I'm going to put a 4 here. Okay. That will give me 4 hydrogens. I only have 2 hydrogens, so I'm going to have to put a 2 there. And then I'll double check everything else just to see. I've got 1 zinc, 1 zinc. Here I have 12 oxygens. There are 6 oxygens here, 4 oxygens here, that makes 10, and then 2 there, that makes 12. So now it is balanced. So again, it doesn't give you the whole balanced equation, but it really did help us to figure out where to get started. Okay. So once you get started, again, whatever you're multiplying by, that's going to go out here on this side, and then you're going to double check your reactant side and see how that balances. So with that in mind, you can go and you can try a couple practice problems on page 613. You've got 16, 17, and 18. The answers for 16 are in the book, and then 17 and 18, if you need help with those, we can do that in a Zoom meeting. All right, good luck.